name is Kwame Tim, and my group members and I are going to be talking about honeypots today. We're going to be talking about what a honeypot is, its capabilities, its challenges, its trends and innovations, some legal aspects, and we wish to also create a honeypot as well. So, without much ado, let's begin. So, one may ask what a honeypot is. A honeypot is a cybersecurity tool that mimics services, resources, or what have you. So let's say you have these resources, right? You have resources, maybe some files, some documents, all of these things, and they are you've you have a CSP that they are on. So that means they're on a network, right? So what this honeypot is that it's going to mimic those resources. Mimic in that sense, it's going to portray itself as it. It's going to pretend to be it. And now the interesting thing about honeypots is that even though they mimic our resources, their security is very low. So we know that the CSPs, they go through a lot of trouble trying to put security onto the things we put into the cloud. So they defend them very well. But for honeypots, the things that are going to mimic these resources or services, they have low security. That is the things that the CSP would implement on the actual resources, they won't implement them on the honeypots, or they implement them but at a very low caliber. So these honeypots are frequent to match attacks. So what this honeypot does is that, like, the main reason for lowering um these security standards or procedures on the honeypots is that we want to trick attackers into thinking that, oh, these are the resources, sometimes to divert their attention from actual resources, or sometimes to when they attack the honeypots, we get to know how they attack, like to track them and to bring up solutions to those kinds of the things. And it's very effective in the case of maybe 0 day attacks. Maybe if a 0 day attack happens, a honeypot is going to be very instrumental. Maybe if you implement a honeypot and an attacker commits a 0 day attack on the honeypot, it's going to be very instrumental in helping you get to know what he did, how to mitigate it, and how to defend yourself. So that was just what a honeypot is. So we are now going to the history or the development of honeypots. So honeypots, the first honeypot was actually created by a man named Clifford Stowe in 1996. So he created, okay, in 1996. Clifford Stowe created a honeypot when a hacker breached his framework while he was at the Lawrence Berkeley National Research Facility in California. Yes. So Clifford Stowe, right? Yeah, Clifford Stowe made this honeypot, but he designed it so that he could track the attacker's way of how the attacker got into the system in the first place. So within the years, these honeypots have developed. Now we have high interaction honeypots, we have low interaction honeypots, as well as the in between, the medium interaction honeypots. So the low interaction honeypots, that's what Clifford Stowe implemented at that. And now that's what we would call a low interaction honeypot. So I told you that the honeypot mimics your resources, your services, anything. So the low interaction one, let's take it. We have some files, right, saved on our cloud, some documents, some important information. The honeypot is going to mimic it. So what the low interaction honeypot does is that it mimics those low grade things like our files, documents, pictures, all those things. The medium interaction or the mild or the mid interaction honeypots, they mimic the files and a bit more user access stuff, grants more privileges and all that. And the high interaction, those ones themselves can mimic whole networks, whole frameworks, and all that. So those ones are very effective to trick attackers and to mitigate all these risks. So now Clifford Store created this low interaction honeypot. Its name was Mantrap. That was the name they gave first ever honeypots they implemented. So from then we are now going to discuss the advancements, technological advancements, the trends and innovations when it comes to honeypots. So I tell you, Clifford Stowe implemented a low interaction honeypot. At that time, there were no high interaction honeypots. It was later in the 2000s that they started coming up with these high interaction honeypots that could mimic entire networks and softwares. And this was very instrumental. As I said, if you could get something that could dupe an attacker, that could look like an entire network or framework, if maybe the attacker isn't that experienced or good, or maybe just a script kiddie looking to play around, he would think that is the actual network. So it would fool him. These honeypots also act as an alert system. So it's sort of like an intrusion detection system. When you enter, it also alarms the network administrator that there's somebody in the net in the honeypot yes has accessed it, and they can monitor all the things that they do. So, to the trends and innovations, now, one is that the integration of artificial intelligence and machine learning into honeypots. So, at first, these honeypots were created in such a way that when an attacker attacked them, all right, they had, let's say, they had the attacks, they knew the attacks, the honeypot itself. There was nothing. Okay, let me take it from there. Like, what if there was a 0 day attack, right? The honeypot has never seen it before. So how can it trace, identify, and give out all those things? But now with the introduction of AI and machine learning into the honeypots, now it can adapt to all these new situations and all that. So even if it is a 0 day attack or is something the honeypot has never come across before, it knows it can adapt to that situation, and it will benefit the person who created it on the network to protect his resources or services. Another one too is honeypots implemented in the cloud. So if for the CSPs, as I said, the CSPs go through a lot of trouble trying to protect our resources that we put on place on the cloud. And honeypot is a very effective way of ensuring that and making sure that our resources aren't scattered in and about. So for these honeypots in the cloud, if I am a user of a CSP, let's take AWS, and I want to protect, and let's say AWS has positioned honeypots on their network to try and dupe attackers from getting my actual information, it's going to be very effective. It's just because they will be tricked into thinking that, oh, these are the resources and all that. So we have other innovations to like cloud collaborative honeypots and intelligence sharing. So that is when a group of companies come together. Like I said, the honeypot also gives information about the attack that took place when the attacker tries to break into it. So these companies can share and cycle all this information to be able to bring out new solutions and standards to mitigate all these kinds of risks and attacks that these people have been developing. So this was just an introduction of honeypots, some new innovations and trends, and what exactly honeypots does. In the next person, my group members are going to discuss into details some capabilities, some challenges, and some all the things that are associated with honeypots. So yeah, thank you very much.
Hello guys, my name is Boashe Adelaide and today I'm coming to discuss with you like some of the capabilities and challenges of a honeypot. So firstly, let's talk about the capabilities, some of the capabilities of a honeypot. So number one, threat detection. So a honeypot detects and identifies potential threats including unknown or zero-day attacks by monitoring suspicious activities and also attracting attackers. So a honeypot lure attackers, allowing for the study of their tactics. Again, improving of incident response. A honeypot provides valuable data for incident response and threat hunting. Please, is that clear? And also monitoring attackers' behavior. A honeypot also monitors attackers' behavior. That's it. But a honeypot also facilitates research. So with this one, a honeypot supports, if we say a honeypot facilitates research, basically what we are trying to say is that a honeypot supports research on threats and attackers' behavior. So that's what I'm trying to say. So there are a lot of capabilities with time, because of time, let's move to some of the challenges of a honeypot. So number one, maintenance and updates. Honeypots requires a regular maintenance and update, which sometimes makes it stressful. Second point, it says difficulty in distinguishing genuine traffic. So a honeypot may sometimes struggle to differentiate, be very, very difficult to differentiate between genuine traffic from attacks. And also limited visibility. Honeypots may not capture all attackers' activities, so it sometimes makes it dangerous to use. And also analyze data analysis complexity. So analyzing honeypot data can be time consuming and complex and sometimes very stressful.
My name is Robert Kojubein, and I'm here to talk about the techniques associated with honeypots in cybersecurity. Okay, so honeypots as a strategic tool in cybersecurity utilizes various techniques to lure attackers, collect data, and enhance defenses. These techniques have evolved over time, even becoming more sophisticated as the nature of cyber threats has grown more complex. Below are some of the techniques associated with the deployment and operations of honeypot. One, we could talk of deception and misdirection. One of the fundamental techniques employed by honeypot is deception. Honeypots are designed to appear as a legitimate system or network, often replicating the characteristics of production environments. This deception misleads attackers into believing they are interacting with real systems, encouraging them to engage fully. These interactions allow the honeypot to capture detailed information about attackers' method and tools that are being used. The direction goes a step further by diverting attackers away from valuable resources and leading them to engage with honeypots instead of actual assets. We can also talk about emulation of vulnerabilities. So honeypots often emulate known vulnerabilities to attract attackers. This technique involves setting up a system or network with specific weaknesses that are common targets for cyber attacks. By emulating these vulnerabilities, honeypots entice attackers to exploit them, revealing their tactics in the process. This technique is particularly useful for studying zero-day exploits and other emerging threats, as it allows security teams to observe how attackers operate when they encounter a seemingly vulnerable systems. We can also talk about hybrid honeypots. So hybrid honeypots combine elements of both high and low interactions honeypots, offering a balanced approach. This system can start as a low interaction honeypot to detect initial scan of probes, or then escalate a high interactions mode if the attacker shows interest. This technique allows organizations to gather detailed information while minimizing the resources required for constant high interaction monitoring. We can also talk about the data collection and analysis technique. A critical function of honeypot is collection and analysis of data. So Techniques associated with this aspect of honeypot operation involve logging every interactions an attacker has with the honeypot, including commands entered, files uploaded, and connections made. Advanced honeypots use machine learning algorithms to analyze this data in real time, identifying patterns and anomalies that indicate sophisticated attacks. The collected data is invaluable for threat intelligence, helping organizations to understand attackers' motive, methods, and the tools that are being used. We can also talk about the intrusion detection and prevention integration. So modern honeypots are often integrated with intrusion detection, system ID, intrusion detection system, into bracket IDS, and intrusion prevention systems, that is IPS. This technique enhances the honeypot's effectiveness by allowing it to serve as a trigger for IDS and IPS systems. When an attacker interacts with the honeypot, the IDS and IPS can be alerted, enabling automated responses such as blocking the attacker's IP address or alerting security personnel. This integration allows honeypots to not only gather intelligence but also actively participate in defending the network. So let's talk about the ethical and legal aspect associated with honeypots. So honeypots are valuable tools in cybersecurity, designed to detect, analyze, and mitigate cyber threats by luring attackers into a controlled environment. However, their deployment raises several ethical and legal issues that organizations must carefully consider. Understanding these aspects is crucial to ensure that honeypots are used responsibly and within the bounds of the law. 1. Ethical considerations. The use of honeypots involves ethical dilemmas, particularly concerning the political for entrapment. Entrapment occurs when an individual is induced to commit a crime they would not have otherwise considered. While honeypots are designed to attract malicious actors who are already intent on provoking it, who are intent on committing cyber crimes, there is a fine line between observing criminals' behavior and provoking it. To avoid ethical breaches, the honeypots should be designed in a way that they do not actively encourage or incite illegal activities but merely observe and document actions initiated by an attacker. We can also talk about legal considerations. So legal issues surrounding honeypots are complex and vary depending on the jurisdictions. One of the primary legal concerns is the legality of gathering and storing of information about attackers, especially when those attackers are located in different countries. So international laws and regulations may differ significantly, and actions considered legal in countries might be illegal in the other. For instance, the European Union's General Data Protection Regulation, the GDPR, imposes strict rules on collections and the processing of personal data, even when the data pertains to cyber attackers. Organizations must ensure that their honeypot activities comply with the data protection law of all relevant jurisdictions. And last, we can talk about consent and notification. Another legal consideration is whether organizations need to obtain consent or provide notification when deploying honeypots. In most cases, organizations are not required to inform the public about the presence of honeypots, since they are primarily designed to detect unauthorized access. However, this could change if the honeypot is deployed in a way that could potentially affect legitimate users, or if the data collected includes personal data that falls under data protection regulations. Organizations must carefully consider the potential need for transparency and disclosure when setting up a honeypot. Okay, so thank you.
So I want to further elaborate on how these honeypots monitor cyber attacks and how they are used as a means to further understand attack patterns and behavior. So let's say let's take a scenario that attacker sees a honeypot, let's say a high interaction in honeypot, it's going to deceive the attacker into thinking that he has found a potential target. So the attacker is going to input information onto that honeypot, and it's going to be is the information is going to be based on the type of honeypot, be it a low or a high. The low honeypot is going to be something like a login attempt, and the high one is going to be something extensive, such as full session logs or something that you can use to pinpoint what exactly the attacker was trying to do. So putting all this together, it helps us to analyze the behavioral patterns of attackers so that we can identify what they were actually trying to do in the network. And if there are any vulnerabilities on the network that the honeypot is mimicking, we can also use it to fix that. So the honeypot allows us to understand the attackers, to get to know what they were trying to do. So normally high interaction honeypots are isolated or placed away from their main or real system. So the attackers can't use them as a launch pad to further any network attacks. So the honeypots are a means by which um, these people or CSP and or these organizations use to identify and understand the behavioral patterns of attackers. And that's- thank you.
Hello, my name is Ibrahim Akafu, cybersecurity student at the University of Mines and Tech. So today I'm going to be teaching you how to create on the cloud service. So you're going to ask, what's a honeypot? So a honeypot is a decoy system that mimics resources. So it's intentionally created with a lot of vulnerability and open ports to allow attackers start thinking that they have access to our real resources. Meanwhile, the honeypot is the decoy, just mimics it, pretends to be the resources, but the honeypot is so the honeypots help us to know what the attacker is attacking, method the attacker to process, how the attacker attacking, the date and time of the attack, the operating system, and the attacker is using to access. So as I said, we are going to be using Amazon Web Service. Let's dive into Amazon Web Service. Okay, so now we are in our virtual machine. So today we are going to be using Kali Linux, which is one of the OS you can use for your virtual machine. Okay, so at this point, I'm going to open my web browser. So in the web browser, I'm going to be accessing the Amazon Web Service. So I'm going to go ahead and open it here. So in the search bar, I'm going to be typing AWS, which stands for the Amazon Web Service. Go ahead and hit enter. Okay, so now that we are on the page of the AWS, I'm going to go ahead to the top here and click on sign into the console. So what we are going to do is that we are going to sign in into our console where we are going to create our instance. So I'm going to click on sign into the console. Going to load for a few seconds. Then we type in our credentials, access our AWS. So as you can see here, you hit root user, then the email address you used to create your account. But if you don't have an account, you can choose to create a new account and sign up here. New to AWS, then sign up. But since I have an account already, I'm going to go ahead and type in my so typing in dot. Okay, so that's my email. So I'm going to go ahead and click on next. Okay, so we're going to type in our password. Okay, so this time, so we are now logged in to our console. So with the console, you can have access to a lot of features here. So this is the cloud platform that we are on. So we can have access to a lot of features that are provided by the Amazon Web Services. So one of the feature that we are going to use today is the EC2. You can see here, I've selected the EC2 already because in it. But if you don't see this on your screen, you're going to go ahead to the search bar and you type in EC2 and then you wait for it to load. Okay, so you can see we have a lot of features here, resources, marketplace, and other stuffs that we can have access to. But today we are using the EC. So I'm going to go ahead, click on the EC. So click on EC. All right. So now that we are in the EC dashboard, we have instances here. So I said in the beginning that we are going to create an instance. So what is the instance? The instance is like we are going to use Amazon's server. So they have servers they provide. So we are going to fetch one for ourselves. Then we use that as so we are going to implement the honeypots on those servers. So the server that we are going to buy. So it's not for free, it's paid. So you have to use credit card paying for sign up. I've already done that. So we're going to click instances. You go to the left of the screen. So we have to wait for it to load. Okay, so now that we're in the instances page, one thing you must realize is that we have here at the top Tokyo, right? So this place, Amazon has a lot of servers all around the world. So they have servers in the US, North Virginia, Ohio, California, and other places. So we are going to choose one of these servers, or we are going to implement our honeypots on one of the servers in these locations. So bear in mind, you have to choose a location for your server. So today we are going to be choosing Tokyo. Well, that's where we are going to implement our honeypots. Right? We're going to choose a server in Tokyo, and then we implement our honeypots on that server. For Tokyo already. So I'm going to go ahead, click on launch for this orange button, this launch instance. So we are going to launch an instance. Okay. Now that we're in the launch instance page, we have to give a name to our server, right? So I'm going to name server cloud. So cloud security. So that is the name of the server. So we are going to give name. We're going to name our server cloud security, right? So you scroll down, please. Now on that server, we have to install an OS. That's it. It's just like our machine. When you buy a computer, you install an OS on it. So what OS are we going to use? Yeah. So we are going to use Debian. All right. So Debian. So we're going to use Debian. Oh, so there are other versions of Debian, Debian 10. We are going to use Debian 12. Okay. So now you can see here we have the OS, which is Debian 12, SSD volume type. So we are going to select the 4 bits and then we'll click on select. So this is the OS we're going to use for our server that AWS is providing us. So this is the OS you're going to use. Okay. Now that we selected our OS, we're going to go ahead to the instance type. To the instance type. So this place, we're going to fetch for ourselves the resources that we are going to use. So what resource are we going to use? So this place, we can select the amount of CPUs we want, the amount of the storage space we want for our server. So I'm going to click on this arrow here. And bear in mind, each server has a price for it. So the price is per hour of our usage. So every hour, the price is so depending on the type of instance you choose, they're going to price you that instance. So you have to choose budget for the you have T2, the free tier, free tier or how you but today we are going to go with the TX large. So the TX large has 4 CPUs, 16 gig of memory. So I'm going to take the TX large by clicking on it large. Okay, and we selected it. So scroll to this. So now here you can see that there's something called key pair bracket login. So the key pair is just like the password that we use to access our computer. So when turning on your computer, you have to log in with your password, enter the password for it. So the key pair is like a password to the server. So we are going to go over here and create a new key pair. So I would advise you to create a new pair, create a new pair so that you are the only person who has access to the server. So we're going to create a pair, we're going to make it cloud. Okay, my PC is plugged in. Okay, I'm going to make it cloud sec. So this is the name of the key pair we are going to use to log in server. So make sure you click on the RSA and the private key format is PM. So the reason why we choose PM for use with Open SSH. The SSH clients or the SSH help us to remotely access our server. So our key pair must be stored in the SSH, the PM, which helps access the SSH, which helps you the SSH format to access our server. So once you go ahead and click on create key pair. Oh, it says our key pair already exists. Okay. Okay, so there. So this is the name of our key pair that's downloaded onto our computer. So you must download your key pair so that you use it to access it. Okay, so I'm going to scroll to the network settings. Okay, so the network settings, once you should PC, subnet is already defaulted. That can create find public IP also enable. So at this point, we are going to leave the security this place and we'll come back later to make a few additions. We are going to add in some rules to the security. Let's leave it like this for now. Then we are going to configure our storage. Now, with the storage, we are going to use 128 or we're going to use 30 GB with 30 gigabytes for our storage. So Why do we need the storage? So the storage, when attackers attack, they're going to save logs of the attack, the process of the attacking, or the threats. So we must provide storage for those log files and that process. So I'm going to use the 30. All right. So I'm going to choose 30, and I'm going to go over here to the down right of the screen, down right side of the screen, and click on launch instance. So this moment we are done with the configuration of it. We are going to launch it. So as you can see for yourself, there's launching instance, creating security groups. Okay. So at this moment, AWS is launching our instance on the server we created in Tokyo, the server that we selected in Tokyo. So the location is very important when it comes to selecting service. So if you choose Tokyo, so always when you want to get access to your server, you must choose the location in Tokyo to get access to it. In case you choose any other places, maybe like Ohio or Kansas or anywhere server is located, you won't see your instance unless you choose Tokyo, which is the location you choose for server. So it says here success launched. We've launched our instance. So this is the ID for instance. So we are going to click on this ID. Okay. So at this stage, this year our instance is up and it's running. So we have successfully created instance. Congratulations to ourselves. Created an AWS. So it's up and it's running. So I'm going to go ahead, select the instance. So click- I'm going to take this button right here, click on next. So now this part is very important. So you have to pay attention. So it says here we should open an SSH client here. Then we locate our private key, the key we use to launch the instance, just like I said. So our private key, cloudsec.pem, just like we did, and we run this command in our shell in the command line. So I'm going to go ahead and copy this code, and we head over to the so we're doing. Okay, now this is our command line. So basic commands, just like friends in class, with the ls. The ls also list the folders we have in the current directory. So now we have desktop documents and downloads. But we are going to use the downloads because since we downloaded our key pair in the downloads folder. So cd downloads. Then we hit enter. Okay. So now this is our key pair, the cloudsec.pm. You can see that we have another pair here. We are going to focus on the one we created just now with the cloudsec.pem. So we are going to paste the code, the command that we copied in the AWS. So Control Shift D, paste it, and hit enter. Now what we have done is that we have unzipped this key pair, or we have made sure that it's not the key pair is not public, but the key pair is private to us alone. So now we are going to go over to our browser again, and I'm going to copy this code right here and head back to our shell. So I'm going to hit Control Shift V. Now This command is going to help us to access the server we created, the instance that we created, the AWS account. So let's go ahead and hit enter. So at this point, we are going to connect the server we created, then we'll continue. So it's giving us an error here. Also place the keyword. Okay, so go ahead and type yes. Okay, so now we log in onto the instance that we created. So the name of our instance is admin at the IP address of it. So now we've logged in. So I'm going to clear the screen so that we see what we are doing. So this is the server that we created into. So now we are accessing the server from here. So this is the SSH clients I was talking about, the SSH. So we've been able to remotely access our server from here. So the next thing we are going to do is that we are going to update our server. So sudo update, not sudo apt update. So sudo apt update. So what this command does is that it updates our server. So I'm going to go ahead and click on. I'm going to go ahead and press. Okay, so now you see that our system is updating itself and we are done. Great. So let me clear my screen one more time. And then we go with the sudo apt upgrade. So what this is going to do is that going to upgrade our system now. So I hit enter and we upgrade. So do you want to continue? Why? Okay, so it's going to take a few minutes to upgrade our system. Okay, so once we are done upgrading our system, let me clear the screen once again so that we see what you're doing. So now we are going to install the honeypot I've been talking about from the beginning on the server. So we are logged in as admin at IP and the IP address. So we are logged in as that name over there. So now I'm going to install a honeypot on it. But the honeypot will be downloaded from GitHub. So I'm going to go ahead. But before we download the honeypot, we have to install some commands for GitHub. So to install a command for GitHub, I'm going to go sudo apt install git. So this command helps you to install the git command. So hit enter. Then I want to continue. Yes. So it's going to take a few moments to install the git command for us. As you can see, we are done with installing the git command. So I'm going to go ahead to my browser here. Then in the search bar, we'll type http. Wait, let me zoom in. I will see what we're doing. Okay, so https colon // github.com /telecom security. Then we hit enter. Okay, so this is the honeypot we are going to implement on our system. So the honeypot was created by the telecom security. So we are going to create this honeypot on. So we go to this tab here, click on it. Okay. So there are a lot of honeypots here which can implement our system. But we are going to stick with the teapot CE. That's right here. Teapot CE. Teapot CE. So at this point, I will head back to my shell. Let's screen one more time. And so in order to install this honeypot from GitHub, we are going to use the command git clone. Then after typing git clone, we type in the URL for the honeypot. So the URL for the honeypot is https colon // then github.com/telecom security /teapot ce dot git. Okay, so this is the URL for the honeypots you're going to install on our. So I'm going to go ahead and okay, so at this point you see that we are cloning the honeypots from the GitHub onto our system. So the system we created on AWS is now going to store the honeypot. As you can see, it's done. So okay, so now that's the folder, the honeypots. So now we'll be able to download the honeypots from GitHub onto our system. So cd teapot ce and we type in the command ls and okay now in the teapot ce folder what we have in the teapot ce folder. So now I'm going to go ahead and install the honeypot on our system. So dot / this is the install. This is the file we are going to install. So dot / install dot sh. Then I hit on enter and y, which is yes, enter. So now we are installing the honeypot of my system. It's going to take a few minutes to install, probably like 2 to 3 minutes. Finish installing. Then we all set. Okay, now it's done installing. So as you can see here, the honeypot is asking us to choose what feature we are going to use. So depending on what we are going to do on our system, we'll choose the feature according to what we are going to do. So now we have something like TPOS standard, which we are going to choose. So we can install other features like the sensor and the mobile, depending on what its function is for. So we are going to stick with the Hive. So I'm going to go ahead, type H, which is for the Hive, then hit enter. Okay, so we are now going to create a username Alright, so I'm going to create a username for my name again. Then it's asking me if my name is correct. So Y, which is yes. And I'm going to create a password. Alright, so I and I repeat my password again. Yes. So now I've been able to create a user account for myself. So at this moment, what's happening here is that the honeypot is trying to install features we have selected, which is the high feature. That's the standard one. So it's pulling the resources that we are going to need for our system. So that's what the honeypot is doing right now. So we are going to relax a while. Probably going to take like 3 to 4 minutes or maybe 5. So we are going to wait for minutes and then everything will be set up. Then we will access our honeypot, our web. Okay. So now the honeypot is done installing on our system. So we have a message here. Please reboot and reconnect via SSH on TCP/64295. Okay. So now what we are going to do here is that the default port for this the SSH is port 22, but it's telling us to log on to port 64,000 port port 64295. So now we are going to log out of the system, log out of the server that we created. Then we'll come back to the local host or the local client, however we want to call it. So now I'm going to use the command sudo reboot. So the sudo reboot is going to reboot my system, going to log me off the server that we created. So I hit enter. So now, as you can see, we are back on our local machine. Let's see, we are back here. So back on machine home from which is my username. So I'm going to go over to my browser. Remember, I said something about the security, which we left like that. So now we are going to go back to the security and add some certain rules, which is going to help us log into the port. The port that was given, so which is port 64295. So I'm going to go ahead, click here, go back to my instance. Okay, so I'm going to click on instances here. Okay, so in the instance dashboard, you will look for security here. Security for the security. That's where I'm going to be changing the rules and adding some rules so that I can access my honeypot. Okay, so now in the security, we have inbound rules and the outbound rules. So I'm going to go here, click on the very link here, load for a while, and add some. So scroll down and you see edit inbound rules. So I'm going to click on the edit inbound rules. Okay, so now at this point, we are going to be adding and make some configurations here concerning the rules I've been talking about. So here I'll change it to custom TCP. So why am I changing to custom TCP? I'm changing it to the custom TCP because I'm going to be adding the ports that was given me in the command line. If you remember the ports number, port two, I don't really remember back to that. So we'll be changing it from here. So let me go back to the port so that I see the number I was given. This port 295. So back to, so I'm going to use port 6, port 6, port 295. So this is the custom port range that I've selected. So the port 6 for 295. Then the IP is going to be my IP because I'm going to access the honeypots through this portal. So my IP for this portion, you see my IP address, which I'm going to cover because it's my private IP. So the description, we're going to type in here this to SSH for. So now we are going to have access to the remote. We're going to remote access to the server that we created with this IP or with this port, sorry, this port number, my IP. So now I'm going to create another rule. I'm going to maintain the custom TCP here, and then we create a new port 64297. So I've created a new port 64297. So this port is from my web browser. I'm going to maintain my IP because I'm still going to access the computer. So in the description, this is for the web portal. Web portal. So this is for our web portal. So I'm going to add the last rule. I'm still going to maintain the custom TCP, but at this point, I'm going to make it a range. So from port 1 to port 64,000. So guess what I'm doing here? So what I'm doing here is that I'm going to open this port, make it available to everyone. So all the attackers. So this is where I'm going to allow the attackers to have access to my through this port, right? So that I'll be able to see their activities, what they are doing, their locations, every detail that I need concerning those who are going to attack me. So the source, I'm going to do it anywhere IP version 4. So the IP version 4, that's where anywhere through this IP, then description, I'll make it this, right? This for the bad guys. Okay, so this is for the bad guys. And I'm going to go over here, save rule. Okay, so now you see that the rules are updating. I've, I've updated my security rules, which I'm going to use now. So now I'm going to click on instances again, sends me back to my instance. Then details. I'm going to click on select instance, click on select one more time. So it brings me to this page. So at this page, I'm going to copy this code, this command again, and head back to my command line. So let me clear my screen. So then I'm going to press Control Shift D. Paste this command. So this command is used to access my server. So now if you look closely here, I have the cloud sec AM, which is the key pair that we created, and the admin here is the name of the server that we created. So the admin at logged in as admin at EC243, that's the IP address. And then this is the location of the server, right? Remember when we were selecting the Tokyo, selected AP Northeast 1 in Tokyo, Northeast. So that's where our server is located, Amazon server. So now, for at least the name of the cloud service we are using, AWS.com. So at this point, we are going to log in back into our server. As you realize here that we have logged out of the server, we're going to log in back into the back. We've changed some rules. So we are going to adhere to these rules to log back in. So to log in through the port number, type P, P, and then the port number that we use. So 642.5. So that's the name of the port. Next to this port. Oh, so it's giving us an error. And it doesn't. So let's see what we are having here. That's the problem. Oh, okay. So what's going on here? Close. Oh, okay. So now, in order to log in into our server, this is what I did not say. We have to go to where I save my key pair. So where I save my key pair so that we can access server through that place again. So I'm going to implement the code, the key pair that they gave us. I'm going to implement again so that I can. I'm going to go over to the browser again. Right. So this very code, this very command right here, command that was given to us right here. I copy the command, go back to so let's so we are going to go into the directory where we downloaded the key pair. So cd download s. Now this is where we have our key pair. So I'm going to go ahead and paste this command again, run it. Now we can access our server now. So let me clear my screen so that I'm doing. All right. So back to this command and we connect. This time we have no error because we did the right thing. We're able to find the mistake that we did. We are connected. Step again. Take some time. Also the verification of the server. Okay. Okay. So as you can see, we are logged in successful as admin IP again. So let's everything is now working. Okay. So now this is where the fun begins. This is where the fun begins. So we are going to our browser again and instances page. So I'm going to wait for them to load the instances for me and we proceed. Okay. So if you can see here, our public IPv4 address. So that's the IP address that was assigned to me. IP address that assigned access instance. So copy and open a new tab. So here I'm going to be accessing the honeypot. So remember we created a port number for the web portal. This is for the web portal. We created one for the command line, one for the web portal, and one for bad guys who are going to attack us. So I'm going to go ahead and type HTTPS colon forward slash then this is my IP. This is the IP, but we are going to log into the port that we assigned. So port 642 97. So the port for my command line is 95, but the port for this one is 97. So I'm going to go ahead, press enter. Let's take a few minutes. Okay, so we are in now. So as you see, it's giving me an error warning, potential security risks ahead. So we are just going to ignore that. Click on that risks. Okay, so now we are getting access. We are now getting access to the port. So I'm going to enter my username, it's Abraham, and so the username and password are the credentials we use to create the honeypot. So now, as you can see, if you log on to the honeypot we created, so port 24040, and we have the features in the honeypot we are going to use.